Hello, welcome to the EPG Pathshala program in linguistics. I am Pramod Pandey, Professor of Linguistics, Jawaharlal Nehru University. I am the principal investigator of this project. We are now going to listen to the presentation of the module Machine Translation 1. This module is one of the modules of a series of 3 modules on machine translation. The author of the module is Dr. Miss Ainura Asamidinova.
Information plays a vital role in the growth of science and technology. Similarly, the growth and development of a language, its culture and literature depends very much on sharing or spreading information. Hence, acquiring, transferring, disseminating and diffusing information is crucial to the development of a human society. Translation is one of the strategies that plays an important role in disseminating information contents from one language to another. Since the last century, this role has been given to machine translation. Machine translation, sometimes referred to by the abbreviation MT, is a subfield of computational linguistics that investigates the use of computer software to translate text or speech from one natural language to another. At its basic level, MT performs simple substitution of words in one natural language for words in another. Using corpus techniques, more complex translations may be attempted, allowing for better handling of differences in linguistic typology, phrase recognition, and translation of idioms, as well as the isolation of anomalies. A machine translation can be classified into several types. One is human-assisted machine translation, that is HAMT, human-assisted machine translation. This is a style of translation in which computer systems does most of the translation, appealing in case of difficulty to a human for help. It involves the help of a human to pre-edit the source language text before being fed to the computer for translating into a target language. Due to the information explosion and the necessity of faster and cheaper translation, HAMT is very suitable for translating text in science and technology, weather reports, equipment manuals, military records, laboratory procedures, articles, research monographs, etc. Since human intervention is required in some form, either pre-editing a source language text or feeding the input or specifying certain grammatical rules, most of the currently available MT systems belong to HAMT, that is human assisted machine translation. Next is machine assisted human translation, MAHT, that is machine assisted human translation, and this is a style of translation in which a human does most of the work but uses one or more computer systems mainly as resources such as dictionaries and spelling checkers as translation rules. The translation is aided by the computer providing suitable word equivalents from the already stored glossary of words. In certain technical and scientific area, conveying the basic meaning is considered to be sufficient through word-to-word translation by MAHT. In recent times, the HAMT and MAHT are grouped together under one term, that is computer aided translation, CAT, computer aided translation, and this covers the meaning of both human assisted machine translation and machine assisted human translation. Next is fully automated machine translation, or FAMT, fully automated machine translation. This is performed without the intervention of a human being during the translation process. Such a completely automated translation perhaps will become a reality one day when the entire domain knowledge with complete and appropriate translation rules are modeled to resolve the syntactic and semantic ambiguities of a natural language. The extensive research in the area of natural language processing, that is NLP, and the various tools of artificial intelligence would certainly lead the way to achieve this goal in the future, at least in the field of science and technology. To know why we need machine translation, we have to look closer at functions of machine translation. Now, there are several goals machine translation is used for. One is dissemination, the production of translations of publishable quality, not necessarily texts that are actually published, but texts that are of that quality. Such texts are required usually by organizations and usually involve professional translators. The raw untreated output from machine translation systems is inadequate, and publishable quality means human assistance. For example, post-editing of the output text or pre-editing of the input, using a control language, or restricting the system to a specific subject domain. In general, it has been found that the more the subject domain of an application can be restricted, the more successful the system is in terms of quality. Another goal is assimilation. The translation of text for monitoring or filtering or skimming information, or the translation of text for occasional users, where the raw output from the system doesn't need to be edited. In other words, where recipients can accept poor quality as long as they can get an idea of what the text conveys. Another is interchange. So here the communication between different languages by individuals, by correspondence, by email, or by telephone is known as interchange. Here again the quality of translation is not so important. As long as people get the information they want, understand the message they receive, or manage to convey their intention, it's fine. Next is database access. This is the use of translation to assist in getting information from a database in a foreign language, one that the user does not well understand. That is, these days this means mainly the use of translation aids for searching the internet, for accessing web pages. While dissemination and assimilation have been traditional uses of MT and translation tools from the beginning, their uses of interchange and database access are recent applications which are growing rapidly, primarily with the growth of the internet itself. The success of a machine translation partly depends on inner architecture of a system. That is the process of handling language in synthesis and generation to give final output. Systems can be built by different axes such as architectures and paradigms. Architectures refer to the actual processing design, that is direct transfer, interlingual, etc., whereas the paradigm refers to informational components that aid the processing design, that is knowledge based, example based, statistics based, etc. Now let's see what type of architectures and paradigms of machine translation systems have been developed by computational linguists. In general, a machine translation system involves feeding the program with a text in source language, after which the text undergoes translation process, and then the machine gives out output in the target language. So you first give the input in source language, and then the text undergoes translation, and then the machine gives out the output in target language. There are direct architecture and indirect architecture. In response to the apparent failure of this direct architecture strategy, two types of indirect architecture were developed, that is the transfer and the use of an interlingual approach. Systems of the latter architectures are sometimes referred to as second generation systems. We'll discuss more on the direct architecture. Direct machine translation is one of the simplest machine translation architectures. In direct MT, a direct word-by-word translation of the input source is carried out with the help of a bilingual dictionary, and after which some syntactical rearrangement is made. The direct method obviously lacks any kind of intermediate stages in translation processes, where the processing of the SL input text leads directly to the desired TL output text. SL is source language and TL is target language. There is no analysis of syntactic structure or of semantic relationships. This approach is unidirectional and only takes one language pair into consideration at a time. It can be characterized as word-for-word translation with some local word order adjustment. It gives a kind of translation quality that might be expected from someone with a very cheap bilingual dictionary and only the most basic knowledge of grammar of the target language. From a linguistic point of view, what is missing is any analysis of the internal structure of the SL, that is the source language, particularly the grammatical relationships between the principal parts of the sentences. Now, it should be noted that it continues to some extent in many unidirectional bilingual systems. In certain circumstances, this approach is still valid today. The most well-known direct empty systems for Indian languages are Anusarga, developed by IIT Kanpur and now being continued at IIT Hyderabad, and Hindi to Punjabi empty system developed at the Punjab University, which achieved an accuracy of 95%. The failure of the first generation systems led to the development of more sophisticated linguistic models for translation. In particular, there was increasing support for the analysis of SL text into some kind of intermediate representation, that is, a representation of its meaning in some respect, which could form the basis of generation of the TL text. This is in essence the indirect method, which is two principal variants. The first is the interlingua approach, where the SL text is analyzed in a representation from which the TL text is directly generated. The interlingua architecture converts words into an intermediate language, which is typically a universal language created for the system to use it as an intermediate for translation into more than one target language. It has an analyzer which produces the intermediate representation of the source language. The synthesizer takes over from the analyzer and produces target language sentences given by the analyzer. The intermediate representation includes all information necessary for the generation of the target language text without looking back to the original text. The representation is thus a projection from the source language text and at the same time acts as a basis for the generation of the target language text. It is an abstract representation of the TL text as well as a representation of the SL text. The method is interlingual in the sense that the representation is neutral between two or more languages. The advantage is that the addition of a new language to the system entails the creation of just two new modules, an analyzer grammar and a generation grammar. By adding one analyst module, the number of translation direction is increased from 2 to 4. The inclusion of another generation module brings another 2 pairs and so on exponentially. While the addition of new languages may appear easy in an interlingual system, there are major disadvantages. A truly universal and language-independent interlingua has challenged the best efforts of linguists and philosophers from the 17th century onwards. At present, interlingual systems are less ambitious though. There are several empty systems in India developed on interlingua approach. Angla Bharati, developed at IIT Kanpur, uses an intermediate structure pseudo-lingua for Indian languages. Angla Hindi is an extension of Angla Bharati, which uses rule-based, example-based and statistics-based methods to obtain translation for frequently encountered noun and verb phrases. The second variant of the indirect architectures is called the transfer method. In fact, all translation systems involve transfer of some kind, that is, the conversion of SL text into the TL text. Dictionary directly converts source into target whenever a sentence matches one of the transfer rules. SL dictionary, TL dictionary and a bilingual dictionary is used for this purpose. The translation mechanism is carried out in three phases. Firstly, the SL is converted into intermediate representation, that is analysis, which is subsequently converted into TL representation in the second phase, which is transfer. And the third phase involves generation of the final target language. Unlike those in interlingual systems, the transfer representations are language dependent. The results of analysis is an abstract representation of the SL text. The input to generation is an abstract representation of the TL text. The function of the bilingual transfer modules is to convert SL representations to TL representations. Since these representations link separate modules, they are also frequently referred to as interface representations. In comparison with the interlingua type of multilingual system, there are clear disadvantages in the transfer approach. The addition of a new language involves not only the two modules for analysis and generation, but also the addition of new transfer modules, the number of which may vary according to the number of languages in the existing system. In the case of a two-language system, a third language would require four new transfer modules. Indian MT systems based on transfer architecture include Mantra, developed by Applied Artificial Intelligence Group of CDAC Pune. Another translation system is the Matra system, also developed by CDAC Pune. There is also Shakti MT system developed by IIT Hyderabad and IISc Bangalore, which works by combining rule-based and statistical methods. Sampark is another translation system which is developed at IIT Hyderabad, and it translates Indian languages to Indian languages, which is based on Paninian framework. The Sampark is deployed in cloud environment, which reduces the deployment time, and distributed system environment, which increases the output. Another important axis of comparison is that of research paradigm. It is important to understand the difference between the type of architecture and the type of paradigm. One does not presuppose the other. Architecture refers to the actual processing design, that is direct, transfer and interlingua, whereas the paradigm refers to informational components that aid the processing design, that is knowledge based, example based, statistics based, etc. Research paradigms are classified into three categories. One, those that propose to rely most heavily on linguistic techniques, and then we have those that do not use any linguistic techniques, and then we have those paradigms that use a combination of both linguistic and non-linguistic paradigms. We will now look into the linguistic paradigms. Until recently, most MT researchers studied linguistic-based MT, that is translation on the basis of principles that are well grounded in linguistic theory. Systems based on linguistic theory strive to use the rules of syntax, lexicon, and semantics to produce an appropriate target language realization of the SL sentence. One such is constraint-based MT, CBMT, that is constraint-based MT. CBMT techniques have shown up several different MT approaches. For example, shake and bake approach demonstrates the full utility of constraint application. Initial approach in CBMT was using constraints on combination of lexical items. This system translates bidirectionally based on lexical functional grammar, that is LFG. In the LFG formalism, F structure, that is a functional structure, is a fundamental component of the translation. Because the LFG-MT system is based on construction-specific representations, the mapping operations required in the transfer must be performed by transfer equations that relate source and target language F structures. The disadvantage of this approach is that the F structure is tightly coupled with the syntactic structure of the language. Thus, if a particular concept can be syntactically expressed in more than one way, there will be more than one F structure in this framework. A more refined version of this approach is currently used in the Verb Mobile MT project. Next is knowledge based machine translation, that is KBMT, knowledge based machine translation. This is a paradigm adopted by developers of numerous US systems including Pangloss, Ultra at New Mexico State's Computing Research Lab, Unicorn by University of Pennsylvania, etc. KBMT paradigm is concentrated on the development of knowledge-intensive morphological, syntactic, and semantic information for lexicon. Tools have been developed for creating ontologies and have provided a framework for automatic lexical acquisition. In general, the focus of research in KBMT has been on the development of underlying knowledge representation concepts. Little attention has been devoted to providing a systematic linking of these concepts to the syntax. Thus, KBMT is complementary to the lexical-based MT and principle-based MT paradigms. In its own, the KBMT provides higher quality, fully automated translations. However, the domains used for this approach are narrow and well defined, since the required amount of information would otherwise be large and cost prohibitive with respect to indexing and searching. Disadvantage in this paradigm is that there is no single systematic mapping between a concept and its surface realization. Next is lexical based machine translation, that is LBMT. LBMT overlaps heavily with several other approaches including RBMT, PBMT, and SBMT. In general, LBMT system refers to any system that supplies rules for relating the lexical entries of one language to the lexical entries of another language. Several researchers have adopted the lexical-based paradigm, but at different degrees of generality. One disadvantage of this approach is that it requires entire trees to be stored in transfer dictionary for each source to target pair. This is significantly burdensome as the number of SL and TL begin to add up. Next, we have rule-based machine translation, that is RBMT. Rule-based machine translation paradigm is associated with systems that rely on different linguistic levels of rules for translation between the source language and target language. One problem with this approach is that it leaves open the question of how grammar-driven interrupts interact with idiosyncratic requirements of individual lexical items. Now we have principle-based MT. Principle-based machine translation, that is PBMT paradigm. This has been developed by a number of researchers, and PBMT is an alternative to RBMT in which rules are replaced by a small set of principles that cover morphological, grammatical, and lexical phenomena in a general fashion. PBMT is considered to be a complementary to the knowledge-based machine translation and example-based machine translation paradigms, in that it provides broad coverage of many different linguistic phenomena but lacks deeper knowledge about the translation domain. We will now look at the non-linguistic paradigms. Non-linguistic paradigms are those that are not based in linguistic theories or even linguistic properties of language. Such research paradigm has been made possible by the rapid advances in computational power and the availability of machine-readable dictionaries and monolingual and bilingual corpora. The approaches all depend on existence of large text corpora, which are used either for training data or database of existing translations. Corpus-based approaches to machine translation tried and partially succeeded to replace traditional rule-based approaches beginning in the mid-1990s following the development in language technology. The main advantage of corpus-based machine translation systems is that they are self-customizing in the sense that they can learn the translations of terminology and even stylistic phrasing from previously translated materials. One of the many problems in the field of machine translation is that expressions convey ideas that transcend the meanings of individual words in the expression. A sentence may have an ambiguous meaning, but each word in the sentence can have many different meanings. Word sense disambiguation is a technique for assigning the most appropriate meaning to a polysemous word within a given context. Word sense disambiguation is considered essential for applications that use knowledge of word meanings in open text, such as machine translation, knowledge acquisition, information retrieval, and information extraction. Accordingly, word sense disambiguation may be used by many commercial applications such as automatic machine translation, intelligent information retrieval, text classification, etc. Despite some success, however, severe problems still exist. Outputs are often ungrammatical, and the quality and accuracy of translation falls well below that of a human linguist. Now we're looking at the statistics-based machine translation. The production of translation based on statistical predictions techniques depend heavily on statistical analysis of bilingual parallel corpora. Earlier investigations on SBMT, that is statistics-based machine translation paradigm, was held in late 1980s by IBM. In less than 2 decades, SBMT has come to dominate academic MT research and has gained a share of the commercial MT market. Progress is rapid and the state of the art is moving a target. This paradigm has been tested in the laboratory for French-English machine translation. The grand claim made for this approach is that no lexicon or grammar are used. Everything comes from statistical analysis of corpora. While this is a strength of the approach, the weakness is that this corpora must exist. IBM later improved its systems by building hybrid systems, adding morphological analysis, POS tagging, syntactic regularization, limited grammatical analysis, and contextual marking. The notable systems in India using statistical MT method are English-Hindi machine translation system developed by IIT Hyderabad, which combines rule-based MT and phrase-based statistical MT paradigm. Another translation system was developed by Cochin University of Science and Technology for translating English to Malayalam, which used statistical MT paradigm. Moving on to example-based machine translation. The basic idea of example-based machine translation assumes a database of parallel translations which is searched for the SL sentences and phrases closest matching a new SL sentence. The translation of the matched phrases are then modified and combined to form a transfer translation of the new sentence. A simple match would be an identical phrase except for a similar content word. The closeness of the match would be determined by the semantic distance between the two content words as measured by some metric based on a thesaurus or ontology. The translation would be the substitution of a translation of the different word in the translation of the best match. The accuracy and quality of translation is heavily dependent on the size and coverage of parallel database. Phrasal matching requires at least a rough syntactic analysis of the parallel translations as well as some semantic analysis to determine the closeness of the match. Sentence translation in EBMT requires that in addition to phrasal matching, the syntactic structure of the SL sentence must be matched with sentences in the database. While full sentence matching has shown some success, most uses of EBMT are restricted to sub-problems such as function words, noun phrases, prepositional phrase attachment, and so on. Although we had all these kinds of different kinds of machine translation, many of non-linguistic based paradigms had difficulty with some aspects of the machine translation process. For example, they cannot handle long range of contextual dependencies or with complex sentences structures. It was quickly recognized that these non-linguistic based paradigms could be combined with linguistic paradigms to exploit the strength of each. And this is how the hybrid MT systems evolved. The hybrid paradigm involves a mixing of MT paradigms as well as mixing of MT architectures. The usual approach is to use linguistic methods to obtain parsers of the SL text and to use statistical or example techniques to resolve dependencies and phrasal translations, etc. Hybrid methods are still fundamentally statistics based but incorporate higher level abstract syntax rules to arrive at the final translation. Such hybrids have been explored in the research community but without any real success because it was difficult to merge the fundamentally different approaches. Now we'll discuss a brief history of machine translation development. It is possible to trace ideas about mechanizing translation processes back to the 17th century. But realistic possibilities came only in the 20th century. In 1933, a French Armenian Georges Artsroni and a Russian Troyansky independently applied for patents for translating machines. Of the two, Troyansky's was the more significant. He envisioned 3 stages of mechanical translation. First, an editor knowing only the source language was to undertake the logical analysis of words into their base forms and syntactic functions. Secondly, the machine was to transform sequences of base forms and functions into equivalent sequences in the target language. Finally, another editor knowing only the target language was to convert this output into the normal forms of his own language. Troyansky envisioned both bilingual and multilingual translations. However, Troyansky's ideas were not known about until the end of 1950s. Soon after the first appearance of electronic calculators, research began on using computers as aids for translating natural languages. By 1952, interest in machine translation had grown enough for the Rockefeller Foundation to sponsor the first conference on machine translation. It was held in MIT in 1952. The conference was a success. The participants were enthusiastic about the prospects and generally had been made aware of the possibilities. Research on MT had begun at many US universities, and in 1954 the first public demonstration of the feasibility of MT was given. Although using a very restricted vocabulary and grammar, it was sufficiently impressive to inspire the establishment of machine translation projects throughout the world. In 1964, the US government sponsors had become increasingly concerned at the lack of progress, so that they set up the Automatic Language Processing Advisory Committee, ALPAC, that is Automatic Language Processing Advisory Committee, which concluded in a famous 1966 report that MT was slower, less accurate, and twice as expensive as human translation, and that there is no immediate or predictable prospect of useful machine translation. It saw no need for further investment in MT research, and instead it recommended the development of machine aids for translators such as automatic dictionaries and the continued support of basic research in computational linguistics. Although widely condemned as biased and short-sighted, the ALPAC report brought a virtual end to MT research in the United States for over a decade, and it had great impact elsewhere in the Soviet Union and in Europe. However, research did continue in Canada, France, and in Germany. The 1980s witnessed the emergence of a wide variety of machine translation system types and from a widening number of countries. First, there were a number of mainframe systems whose use continues to the present day. The wide availability of microcomputers and of text processing software created a market for cheaper machine translation systems. Other microcomputer based systems appeared from China, Taiwan, Korea, Eastern Europe, Soviet Union, etc. Throughout the 1980s, research on more advanced methods and techniques continued. For most of the decade, the dominant strategy was that of indirect translation via intermediary representations, sometimes interlingual in nature, involving semantic as well as morphological and syntactic analysis, and sometimes non-linguistic knowledge bases. In the early 1990s, a group from IBM published the results of experiments on a system based purely on statistical methods. Secondly, certain Japanese groups began to use methods based on corpora of translation examples, that is, using the approach now called example-based translation. In both approaches, the distinctive feature was that no syntactic or semantic rules are used in the analysis of text or in the selection of lexical equivalents. Both approaches differed from earlier rule-based methods in the exploitation of large text corpora. A third innovation was the start of research on speech translation involving the integration of speech recognition, speech synthesis, and translation modules. The latter mixing rule-based and corpus-based approaches. The major projects are ATR, the collaboratives of Janus project, and in Germany the government-funded Verbmobile project. However, traditional rule-based projects have continued. Another feature of the early 1990s was the changing focus of MT activity from pure research to practical applications to the development of translator workstations. These trends have continued into the later 1990s, in particular the use of machine translation and translation aids by large corporations has grown rapidly. A particularly impressive increase is seen in the area of software localization. There has been huge growth in the sales of MT software for personal computers as well. In the recent years, achievements have been made in development of translation tools, for example, terminology databases and translation memories. With these translation workstations, human translators are in control of computer facilities, producing output which they can edit, correct, retranslate, or reject. Another milestone in MT is the development of systems for spoken language translation. Although at present it encounters with speech recognition and automatic translation problems, however, progress is being made. The impact of internet has been significant in recent years. Rapid growth of real-time online translation on the internet is caused by the need for software to translate web pages, electronic mail, and other internet resources and text, either offline or online. The availability of on-demand internet-based translation services for companies. There has been a rapid increase in MT software products designed specifically for online translation of web pages, emails, and chat.
So in this presentation, we have listened to the discussion of the notion of machine translation. We discussed the goals and types of machine translation. We also learned the difference between architectures and paradigms of machine translation systems. We examined linguistic and non-linguistic paradigms employed in machine translation systems, with some examples of machine translation systems developed in India. In the course of the coming modules, we will look at some of the issues and problems in the development of machine translation systems in India and in the world in general. Thank you.